The way we interact with the universe around us has been changed forever. Welcome to WatchMojo News, the weekly series where we break down news stories that might be on your radar. In this installment, we're counting down 5 need-to-know facts about Einstein's gravitational waves. Number 5. What are gravitational waves? Gravitational waves were first predicted in 1916 by Albert Einstein as part of his theory of general relativity. The waves are a transportation of energy through space-time whenever an object accelerates or moves. The effect is similar to that of a boat traveling through water, creating ripples, or of a heavy object being dropped onto a trampoline, shifting tension toward the center. Crucially, gravitational waves travel unimpeded across the universe, whereas light may become blocked out or softened over space and time. Gravitational waves are unchanged by intervening matter between their source and us. Therefore, to receive gravitational waves is to engage with parts of the universe previously impossible for humans to observe. Number 4. What is general relativity? The general theory of relativity was published in 1915 and forms the basis for Einstein's prediction that gravitational waves existed. It's essentially a rethink of Isaac Newton's classical law of universal gravitation, developed in the late 1600s. Einstein's theory says that gravity isn't a specific force, but the natural result of matter and energy existing in space-time. Large objects such as the Sun and Earth displace energy in space-time and pull smaller objects, like people for example, inwards. The idea allows us to view the universe as though it's a kind of landscape, a geometry in which the place and movement of all objects, planets included, are dictated by the curvature of space-time in which they exist. Therefore, because of the apparently infinite reach of gravitational waves, the theory can also help us understand the history of the universe, potentially as far back as the beginning of time. Number 3. How were they discovered? The first detection of gravitational waves occurred at almost 9:51 Coordinated Universal Time on September 14, 2015. The observation, which consisted of a chirp signal lasting 0.2 seconds, was recorded by the Laser Interferometer Gravitational Wave Observatory, or LIGO, detectors at Hanford, Washington State, and Livingston, Louisiana. After follow-up tests and analysis, the recording was granted a confidence level of 99.99994% and presented as an almost certainly legitimate result. The signal came from the merging of 2 black holes over 1.3 billion light-years away from Earth. The black holes would have been spiraling toward each other with increasing velocity before combining, at which point the gravitational wave was strong enough to be detected by the most sensitive technologies on Earth. Executive Director of LIGO, David Reitze, announced the breakthrough on February 11, 2016.
We have detected gravitational waves. We did it.
Number 2. How did the world react? Across the planet, scientists greeted this chirp with excitement. Reitze explained that, quote, "Up until now, we have been deaf to gravitational waves, but today we are able to hear them." While Dr. Szabolcs Marka, an astrophysicist at Columbia University, said, quote, "The skies will never be the same." Renowned Royal Society professor Brian Cox said, quote, "This opens up an entirely new way of observing the universe." Professor Alberto Vecchio of the University of Birmingham and a member of the team behind the detection elaborated, quote, "This observation marks 3 milestones for physics: the first detection of gravitational waves, the first observation of a binary black hole, and the most convincing evidence to date that nature's black holes are the objects predicted by Einstein's theory." For Professor Karsten Dantzmann of the Max Planck Institute for Gravitational Physics, the significance is clear. He says, quote, "There's a Nobel Prize in it. There is no doubt." Number 1. What does this mean for science? This has been labeled as one of the most important developments in modern science, on a level with the discovery of the Higgs particle and the decoding of DNA. It's also been listed as the most significant step in our understanding of space, since Galileo pioneered the telescope. Humankind is now able to hear the universe beyond even that which it can see, and the LIGO detection could be a major step in answering humanity's greatest questions. Scientists anticipate similar detections to occur with increasing frequency, especially regarding some of the universe's most powerful and destructive events, such as neutron star collisions. Looking further into the future, though, gravitational waves could help us understand previously invisible dark energy. And then there's the ultimate quest to provide an answer to the ultimate question.
42.
Theoretically, there should be gravitational waves out there carrying the imprint of the Big Bang, which could provide humans with details as to how and why the universe was initially created.
The ultimate question.
Did these facts get you thinking?
Yes, I thought it over quite thoroughly.
To vote for which news story is covered next, head over to WatchMojo.com/suggest. And be sure to hit that subscribe button for more newsworthy top 10s published every week.